So, good afternoon, students. So today we will going to start about the next topic for your JAM economics paper. Okay. So today we will cover the mathematical statistics part of this of JAM syllabus, that is mathematical statistics. So in this portion we will cover about random sampling, so good morning, student. So in today class we will learn about the correlation and regression. Okay, so let me start. So the JAM syllabus for the economics for correlation is very short of, like it only contain correlation and types of correlation, and after that we will see some of the previous year questions that come in JAM economics paper related to correlation and regression. Okay, so start with, first of all, what is correlation? So correlation is nothing but it is a statistical measure. So let me write, correlation is a statistical measure that express the extent to which two variables are linearly related. So this is a definition of the correlation, but before that we will should know what is the meaning of correlation. Okay, so the simple meaning of correlation is that if a change in one variable affect the change in the other variables, then the variables are said to be correlated. Okay, so what it's mean, let me write first. If the change in one variable affects the change in the other variables, then variables are said to be correlated. Okay, for example, suppose we have x, let me draw, we have some data point here x. Okay, then what we see when we find the correlation, we find that the both are highly correlated. Highly correlated means that if we increase the x, then y should also be increases. Okay, this is the meaning of the correlation, but before that we should know what is scatter diagram. Okay, so what is scatter diagram? So it is a simplest way of the diagrammatic representation of bivariate data. Okay, from scatter diagram we can form a fairly good idea whether the variables are correlated or not. See, this is a diagram which I have drawn here. This is known as the scatter diagram, and correlation just tell that how they are how they are linearly related. Like it give the number, for example 0.95, that 95% of the variables are linearly dependent. Okay, so I have write the definition of the correlations. Now come to the formula. Karl's Pearson coefficient of correlation. Okay, so he's the man who just developed the formula for the correlation coefficient. His name is Karl Pearson. Okay, so it as a it is a numerical measure of linear relationship. Okay, so what is the formula? So formula for the correlation is defined like covariance of xy divided by standard deviation of x, standard deviation of y. So this is the formula for correlation. Okay, and then let me elaborate more this formula. So if xi, yi are bivariate mean there are two variables x and y. Okay, is a bivariate distribution, then how will you write covariance? Covariance of xy can be written as expectation of x minus expectation of x and y minus expectation of y. Okay, so when you will just elaborate more, it will come like 1 by upon n sigma xi minus x bar into yi minus y bar. Okay, now let me come to the next page. Yeah, then after it is a variance of the x, that is expectation of x minus expectation of x whole square, that is 1 upon n sigma xi minus x bar squared. Okay, and this is sigma square y is the variance of y, that is y minus expectation of y square, that is 1 upon n sigma yi minus y bar whole square. Okay, now the summation is from 1 to n. Okay, so the final formula will be covariance of x y is equal to 1 upon n sigma xi minus x bar into yi minus y bar, that is when you take the multiplication summation, we will get xi yi minus x1 y bar minus x bar yi plus x bar y bar. Okay, take the n, multiply n with all the, that we will get sigma xi yi minus y bar, because y bar, and 1 upon sigma xi minus x bar 1 upon sigma yi plus x bar y bar. Okay, now when you see this will x y bar x bar y bar x bar. Okay, so this is to let me write this 1 upon n sigma xi yi. Now minus y bar x bar minus x bar y bar, because this term will become x bar and this term will become y bar, plus x bar y bar. Cut, what will you get? We will get this xi yi minus x bar y bar. Okay, and what we get from the and for the sigma square x we get this, and sigma square y we get y. So at last we will write that covariance of xy divided by sigma x into sigma y is equal to 1 upon n sigma xi yi minus x bar y bar divided by under root of 1 upon n sigma xi into x bar square into 1 upon n of sigma yi minus y bar square. So this is your formula for the correlation coefficient. Now we will see some of the plot, okay, and we will see like what is the types of correlation. So first of all, this, let me draw 3 plots. Yep. So see here, it is your x y y x x y. Now so these are your data, okay. Now here what you see, here you see when x increases y also increases, okay. X increases y also increases. So what does it mean? It's mean that it is a positive correlation, okay. Sorry, correlation, okay. Here what you see when x increases y decreases. So here it is negative correlation. And here see when increasing x there is no changes in y because these are quite independent, so it is no correlation. So there are 3 types of correlation: positive correlation, negative correlation, and no correlation. So in positive correlations what happen, if the variable x increases y also increases, so it will see a positive correlation, okay. And here you can see the x increases y decreases, so it shows the negative correlations, and here there is a no correlations, okay. So let's see the limit of the correlation. Yeah. Limits for correlation coefficient. Okay, so what we have the correlation. Always remember the correlation is denoted by R, that is covariance of xy divided by sigma x sigma y, that is 1 upon n sigma xi minus x bar yi minus y bar and root of 1 upon n sigma xi minus x bar into square 1 upon n sigma yi minus y bar square, okay. Now what we will do, we take ai here, that is equal to xi minus x bar, and bi here, that is yi minus y bar, and we multiply both side by r square, okay. So multiply both side r square xy, and let me write here sorry, not square, square both sides. So what we'll get, r square x is equal to sigma ai bi square, because you can see xi minus ai is equal to ai and yi minus y bar is equal to bi, divided by sigma ai square into sigma bi square, okay. Now we use the Squart's inequality, okay. So Squart's inequality is used to make the relationships between the 2 variables x and y, okay. So we will use Squart's inequality, and this inequality is not very important for your exam point of view, because we use this inequality in statistics to prove some of the relations, okay. So what does Squart's inequality say? Squart's inequality say summation ai bi square should be less than summation ai square, and this proof is also not important for your JAM exam point of view, but I just make it so you should remember at least. Okay, square n sigma bi square. Okay, now the sign of inequality only hold if when this sign of inequality hold. So the sign of equality holding if and only if a1 upon b1 is equal to a2 upon b2 is equal to an upon bn. Okay, so using Schwartz inequality, what we will get r square xy is less than equal to 1, that is sigma of, sorry, not sigma, modulus of r xy is less than 1. So from here what we get, from here we get -1. You know, when we break the modulus sign, we will get like this. So this is nothing but it is your correlation value that tell that correlation coefficient always lies between -1 to 1. Here one, if rxy is equal to 1, that it is purely positive correlated. Okay, and if rxy is equal to -1, it means negative correlated, and when rxy is equal to 0, it means no correlation. So this is the value. Okay, now we have some of the formulas, some of the theorems. I only write the theorem, the proof is not important, but you should remember these proof. Okay, 1 minute. Theorem 1. What does it mean? Correlation coefficient is independent of change of origin. 1 minute. Correlation coefficient is independent of change of origin and scale. Okay, what does it mean? If you change the origin and scale, but the correlation coefficient is same. Okay, now we have one corollary. What does it mean? See, if like these are used mainly for solving the questions. Okay, if x and y are random variables and a, b, c, d are any number provided only that a is not equal to 0, c is not equal to 0, then what will be the correlation of a x plus b c y plus d? That will be equal to ac divided by modulo of ac r xy. Okay, we will see the proof of this. See this, like you should remember this formula, because sometimes in examination we will like they will ask that find the correlation of like 3x plus 2 or 2y plus 5, then you should use this formula and just get the answer. Okay, so the proof is quite easy. See, variance of ax plus b is equal to a square sigma square x. Variance of cy plus d, that is equal to c square sigma square y. Okay, now covariance of ax plus b into cy plus d. So this formula is I am taken from the like this formula I have described in the covariance lecture. Okay, so I will write it here directly, sigma square x y, sorry not x square here, sigma xy. Okay, now just put the you will get correlation of 3cy plus d divided by variance of ax plus b, variance of cy plus d half, that is equal to ac sigma xy modulo of this sigma x sigma y. And we will write it like, see, when we take this out we will get r x y. So this is the formula. Okay, now if AC is greater than 0, that is A and C are of same sign, then AC divided by A is equal to plus 1. Or if AC is less than 0, means A and C are of different, sorry not different, opposite sign, then AC by AC, yeah, I just left the C is equal to minus 1. Okay, so this is one of the corollary. Now I move to the second theorem. Second theorem, what means? Two independent variables are uncorrelated. Okay, simple, just if the two variables are independent. So covariance of the independent variable is 0 as x and y are independent. So Rxy is equal to covariance of xy sigma x sigma y is equal to 0. What does this theorem mean? That two independent variables are uncorrelated. Now we will come here to solve some of the questions, so you will get a idea at how will we solve it. Okay, but one important theorem we should know, that I will make it end. But the converse of the theorem is not true. What does it mean? Means two uncorrelated variables may not be independent. Okay, what does this mean? See, two independent variables are uncorrelated, but two uncorrelated variables may not be independent. Okay, always, like, this question should be asked in examinations, like which of the statements are true? Two independent variables are correlated and two uncorrelated variables are not independent. Then you should know that what does it both line mean. Okay, so two uncorrelated variables may not be independent. It may be independent, it may not be independent. Okay, so let's solve one easy questions. Okay, so what is the easy questions? Calculate the coefficient of correlation between x and y. Okay, so what is x? So here x and y, so we have x 65, 66, 67, 67, 68, 69, 70, 72. We have y 67, 68, 65, 68, 72, 72, 69, 71. So okay, so what is the formula for the correlation? The formula for the correlation is, let me write here, Rxy is equal to covariance of xy divided by so of x variance of y. Okay, that is 1 upon n sigma xy minus x bar y bar divided by under root of 1 upon n sigma x square minus x bar square. I have just open the summation. Okay, sorry, open the bracket. This is 1 and 1 upon n sigma y square minus y bar. Okay, now what we have to find? We have to find x square, x bar square. So let's start while finding. Okay, see, I will use this page here. So x here, y here, x square here, y square here, x y here. X is what? 65, 66, 67, 67, 68, 69, 70, 72. Y here is 67, 68, 65, 68, 72, 72, 69, 71. What is the total? If you add that, you will find 544 days total, here 552. Now x square, take the square of the 65. So 65 square is 4225, 66 4356, same 4489, 4489, 4624, 4761, 4900, 5184. And y square 4489, 4624, 4225, 4624, 5184. Let me write this clear: 4624, 5184, 4761, 5041. And what upon xy? Multiply x and y, like 65 into 67, we get 4355, 4488, 4355, 4556, 4896, 4968, 4830, 5112. Now we just add it here. Okay, now simple, calculate the x bar, that is 1 upon n sigma x, that will equal to 544 upon 68. Okay, sorry, not 68, 8, that is equal to 68. Then calculate y bar, 1 upon n sigma y, that is 552 divided by 8, that is 69. Okay, now just simply put the formula and you will get the answer, that is 1 upon n sigma xy minus x bar y bar, 1 upon n sigma x bar, sorry, x square minus x bar square, 1 upon n into y square minus y bar square, that is 1 upon 8 into 37560 minus 68 minus 69 divided by 37028 divided by 8 minus 68 whole square, and 38132 by 8 minus 69 whole square. And you will get the answer after solving this, 0.603. So 0.603 mean you have like like how it is correlated. It will correlate like this for x and y data, and it is positive correlated. Okay, so this is the topic on correlation, and there is one more type, that is regression. Like how will you find the regression? Okay, so let's start the linear regression topic. Okay. Linear regression. Okay. So if the variables in the bivariate distributions are related, we will find that the point in the scatter diagram, like a cluster round sum, that is called the curve of regression. Okay. So let me first define what is regression analysis. So first of all, what is mean by regression? So these all the notes I have just written here, I will use my class notes that I have making in my masters. Okay. So regressions mean stepping back toward the average. Okay. So regression analysis is a mathematical measure of the average relationships between two or more variables in terms of the original unit of data. So this is your definition of regression analysis. Okay. Now, so in regression analysis, we have two types of data. In regression analysis, we have two types of variables. Okay, that is dependent variable or independent variable. Okay, now the variable whose value is influence or is to be predicted is called dependent variable. Okay, like dependent variable is that variable whose values influence means or predicted. Okay, like for example, I will see an example, or the variable which influence the values or use for prediction is called independent variables. Like this, for example, y is equal to mx plus c, a simple linear equation that you have studied in mathematics in class 12. So in y mx c, you will know why it is dependent, because it depend upon x, it depend upon m, it depend upon c, but here x is independent. Does not depend on anyone, and this m is a coefficient of x which is calculated using the values of the x. Okay, now we will come to the linear regression. Okay, So linear regression is what? Okay, now if the curve is, now what we have told you, that curve of regression. So first of all, let me define that. So if the variables in a bivariate distribution are related, we find that the point in the scatter diagram will cluster around some curve called curve of regression. Okay, now, or if the curve of regression is a straight line, then it is called linear regression. Or if curve of regression is straight line, it is called linear regression. I will explain with the help of example. So suppose like this. See, this is your variable x and variable y. Okay, you have some point like this, x, then you will fit a line, that best you will fit the line, and this line is known as linear regression. And what does it mean? The line of the regression, this is what we call, I'm sorry, I just stated linear regression, it will the line of regression. Okay, what does it mean? It's mean that the line of the regression is the line which gives the best estimate to the value of the one variable for any specific value on the other variable. Okay, so let me write this. What does this line give? So the line of regression क्या देगा हमें? Line of regression will gives the best estimate to the value of one variable for any value of other variable. For example, if you want to ask that what is the value of x is equal here, so you, by using this line, you will not to know that this and this. So for the specific value of x, the specific value of y is this. Okay, now, so what is the equation of this line? So the equation of this line is, I will use this line. So what is the equation? So the line of regression of y on x is y is equal to a plus b x. Okay, now a and b are the coefficients. A and b are coefficients. Now the problem is to determine this a and b to the line that to the so the problem is we have to determine the equation when you plot this line, you have this is the equation of that line, and the problem is that we have to determine the value of a and b in such a way that the line this line is the best fit line. Okay, let me show you one more time. See, this is the equation. So this is x and this is y. Okay, and when you plot, we will get many lines. Okay, you will get the many lines in the data, but which line you should prefer? If I am asked that if we have the variables, say x, y, say these are the data. Okay, these are the data, and you have these many lines, so which line you prefer? So you will prefer that line. So each line have its equation. Each line have its equation. So you will find the best fit line from this best fit line. we will find the best fit line here. And how will you find the best fit line? So we will find the best fit line by using the principle of least square. Okay, I will write it. We find the best fit line by using the principle of least square method. Okay, principle of least square. In following line, we will use the principle of least square method to find which of the line is the best. Okay, and what does its principle least square means? So in the principle of least square means, I will use different color. So the principle of least square means principle of least square consists of minimizing the sum of squares of the deviation of the actual values of y from the estimated value given by the line of best fit. Okay, so what does it mean? It's mean that the principle of least square consists of minimizing the sum of the square of the deviation of the actual value y minus the estimated value. What will be the estimated value? So estimated value is a plus px, and we will just minimize it. Why should we minimize it? Because see, this is your true value and this is your predicted value. Let me show with the help of a plot. So suppose we have this line, okay, and this is our best fit line. Let's suppose for 1 minute that this is our best fit line, and we know for x is equal to 3 we get y is equal to 5. For x is equal to 3 we will get 3 4 5. Let's suppose the x is let's suppose the best fit line is that. Okay, now we fit the best fit line, and instead of this my best fit line is some like how this is my best fit line and this is my true line, but here we use the best fit line. So when we have the best fit line, then we find that for my x is equal to 3 we get 4.5 in best fit line. X is equal to 3 is equal to y is equal to 4.5. Then we should minimize this error, means 5 minus 4.5 squared. We have to minimize this for all the values, like it is only for the single value, but when we minimize it we have the many values. For example 10, 20, 40. We will see an example, you will clear by them. Okay, I hope you understand why we minimized it. Okay, let's go. So the we have the y minus yi, because yi is equal to number of points, minus a plus bxi. Xi is equal to number of points, yi is equal to 1, I is equal to 1 to 2 dot n. Xi is equal to where I is equal to 1 to 2 n. Okay, so what does it mean? What does we call it? We call it as error or estimate. Error of estimate or residuals of y. For y, why residuals? When we have the true value and we minus the estimated value, the left is called residuals. Residual bit, that is the error part. Okay, and according to the principle of least square we have to minimize the error, because when we minimize the error we will get the best fit line. For example, in examination we have that kept the 10 marks, and sorry, in your mock test you get the 10 marks, and in examination we get the 5 marks. So what is the error? 10 minus 5, that is 5 error, and your motive is to minimize that error. Like in the next mock you will, in the next examination you will score much more, like the error will minimize to 4, then 3, then 2 to 1. So what is your best case? So the best case is that you will minimize the error to 0. Okay, so here we will use the same approach. So according to the principle of least square, we have to determine A and B. So what does we do? So we minimize this error terms, and by minimizing we get the best value of A and B, because the A and B should be the value that minimize the error term. So we will write it for all values. So that will be summation is equal to 1 yi minus a plus bxi square. Okay, just remove the internal bracket. We will get yi minus a minus bxi square. Okay, now you have learned about the minimization and maximization in your bachelor's or in your class 12. So I will use the same approach. So we differentiate, this is the error term, differentiate error with equal to a 0 and with b is equal to 0. Okay, so first case, when d by dA, because we have to find the value of it, that's why we will differentiate with 0. That will equal to minus 2 sigma, see 2 will come here, yi minus a minus bxi is equal to 0. Okay, so what we'll get here, you will get open the summation, take the to that side, yi is equal to na plus b sigma xi. How? See, when you have summation with a, that is equal to na, because a dot n times, that is na, and when we multiply with a, that b should be constant, so b should be outside, and it will go to sigma bi, sorry, sigma xi. Okay, so let me give it in bracket. Now for b, de by db is equal to 0, that is equal to minus 2 sigma ni is equal to 1 xi into yi minus a bxi. See, this is simply the differentiation. Okay, you should know that how to differentiate these. Sigma xi yi ni is equal to 1, that is equal to a sigma xi n plus b sigma xi square n I is equal to 1. Okay, so while you differentiate this, you will get this. Now what these equations do? So these equation, let me give it number 1 and number 2. So equation 1 and 2 are known as the normal equations for estimating A and P. Okay, and all these points around sigma xi squared, sigma y, is these all value you will estimate using the data that is available to you. Okay, now get back to the equation. So from first on dividing by n, so when we divide this equation 1n, let me write it, yi na plus b sigma xi divided by n both side. What will you get? You will get here is y bar nn a plus b x bar. So from here we get the value of a. Yep, that is ya is equal to a plus b x bar. Okay, what does it mean? So this is the line of regression of y on x. See, y on x passes through point x bar y bar. So this equation is passes through point x bar and y bar. Now now see, I will use the correlation functions here. So what we know, covariance of xy is equal to 1 upon n sigma ni is equal to 1. We will use the correlation term in the regression as well. x1 xi minus yi minus x bar y bar. Okay, now can we write this like that? Sigma ni is equal to 1. Oh, okay. For okay, now for let here I will use some small notations because it's quite large. Okay, for some instant, let's say covariance of xy I will read at y11. Okay, for some times I will use covariance of xy is equal to mu 11. Okay, like so from here we can write it mu 11 plus x bar y bar. Okay, and also we know that sigma squared x is equal to 1 upon n sigma xi squared minus x bar squared. 1 upon n sigma xi squared can be written as from here that is equal to sigma squared x plus x bar square. Okay, see I just use the transformation like I will calculate the 1 by n sigma xi square. Why I have calculated it? Because see in here I need sigma xi square. I need sigma xi square here. I need sigma xi yi. Okay, that's why I am using the correlation function. Now divide equation 2 by n and I will give some number to here as well. That is 3, that is 4. Okay, divide by n and using equation 3 and 4, that is mu 11 plus x bar y bar is equal to a x bar plus b sigma square x plus x bar square. Okay, now okay, say it is equation 5. Now multiply, see the proof is not important for the exam point of view, but you should know that how it will came. So multiply equation 5 by x bar and subtract from equation 6, and this is your equation 6. Okay, what does we get? Okay, so multiply equation 5 by x bar, so that is x bar y bar is equal to x bar into a plus b x bar. Okay, and then subtract from equation 6. When we subtract, so after subtraction we will get mu 11 is equal to b sigma square x, that is equal to b is equal to mu 11 by sigma square x. And what is mu 11 here? It is a covariance. Now b is what? So b is the slope of the line of regression, line of the regression on y on x. Okay, since the line of regression passes through point x bar y bar. Okay, now what does its equation mean? Since the line is passes through x bar, then you know the y line equation, y minus y bar is equal to m into x minus x bar from the slope equation in class 12. Yeah, I will use that because see these all are the basic concepts. Okay, but these are a little bit modified using the variance, correlations, that's all. Y minus y bar is equal to beta x minus x bar, that is the equation I am talking about. That what we will write? We will write mu 111 by sigma square x into x minus x bar. So the final equation will be y minus y bar, that is r sigma y by sigma x into x minus x bar. And I know that you will like ask how it's come. So see, this is covariance. So let me mu 1 by sigma square x. It is covariance of x y by sigma square x. And what is correlation? Correlation is equal to covariance of x y into sigma x sigma y. So multiply r sigma x sigma y is equal to covariance of x y. So just put it here, r sigma x sigma y sigma square x, it cut r sigma y sigma square x, that I have used it here. Okay, so this is what the regression of y on x. Okay, what will if we call the regression of x on y? So regression of x on y, what will we get? We will get x minus x bar r sigma x sigma y to y minus y bar. See, just you have to interchange, just take the reciprocal, rx will be up and ry is equal to down. So this is your equation. Okay, let me see anything. Okay, now so there is some particular cases. So case 1, okay, so in a case of perfect correlation, what is perfect correlation? That is positive or negative, that is +1 -1, r is equal to. Okay, so the equation of line become, the equation of line of regression of y on x will become y minus y bar is equal to plus minus sigma y upon sigma x, x minus x bar. Little bit of change, you will get this. This will. Or similarly, in a case of x on y, just yep, this. Okay, okay, so there is some of the properties of the regression coefficient. This is the last topic, and after that we will come to the OLS or ordinary least square, then some of the assumptions. Okay, but I will discuss these concepts in the next class, not in this. Okay, okay, now properties of regression coefficient. Let me see if time permits, can we solve one example or not. Yeah, we can solve one examples. Okay, so see, I will only define the properties, not I am going to prove it. Okay, now the first property is correlation between, sorry, correlation coefficient is the geometric mean between regression coefficient. Okay, what will bxy into b yx. What did it mean? R sigma x sigma y into R sigma y sigma x. This will be cut out, this will be cut out. That is R square. That is R is equal to under root of bxy into byx. What is byxy? Byxy is a correlation coefficient of x on y, and byx is equal to correlation coefficient of y on x. Okay. Now, the second is, if one of the regression coefficient is greater than unity, the other must be less than unity. Okay, see, if byx is greater than 1, that what imply 1 by byx is less than 1. Okay, this what it's mean. Okay, now the angle between two, this is very important. Angle between two lines of regression. Okay, so equation of line of regression y on x and x on y, that is y minus y bar is equal to r y by lambda x into x minus x bar. Same, x minus x bar is equal to r sigma x sigma y y minus y bar. Okay, how will you find the angle between them? So you have remember in the class 12 we use the tan theta. Okay, so just we use the tan theta, tan one minute. Tan theta is equal to r sigma y by sigma x minus sigma y by r sigma x divided by 1 plus, this is the formula, tan theta is equal to tan a plus tan b by 1 minus tan a tan b. Okay, 1 plus r sigma y sigma x into sigma y r sigma x, that is equal to r square minus 1 by r into sigma x sigma y sigma square x plus sigma square y. After solving you will get this. Okay, so the angle is equal to tan inverse 1 minus r square by r sigma x sigma y sigma square x plus sigma square y. Okay, so this is your angle. If r is equal to 0, tan theta become infinity, that is theta is equal to pi by 2. Or if r is equal to plus minus 1, tan theta is equal to 0, means theta is equal to 0 or pi. So this is concepts. Okay, so this is from my side. So in the next class we will see some of the econometrics models, and after that after I complete that we will go to solve the previous year questions that come from the correlation and regression points of view. Okay, so thank you and see you.
जेएनयू के बारे में सबसे बेस्ट चीज आपको क्या लगता है? आने वाले सीयूईटी एस्पिरेंट्स के लिए आप क्या बताना चाहते हैं? कुछ सजेशन, तो आप बच्चों को क्या बताना चाहते हैं जो कंफ्यूज रहते हैं, डीएससी आना चाहिए या जेएनयू आना चाहिए? ये आप बताइए। बच्चे ये जानना चाहते हैं जेएनयू में मेरा एडमिशन हो गया, तो उसके बाद मुझे हॉस्टल मिलेगा या ना मिलेगा, आने वाले सीयूईटी एस्पिरेंट्स जो भी हैं, जो प्रिपरेशन कर रहे हैं और आना चाहते हैं जेएनयू, डीएसी, आईजीआईडीआर, तो उनके लिए आप क्या सजेशन देना चाहते हो, वो किस एरिया में ऊपर उनका